Linearly independent vectors. Consider a parallelogram ABCD. Explain why each of the vectors AB, AC and BD are linearly independent with each of the other vectors. So that is the question. This time we are discussing about linearly independent vectors. So let's have a good look at it. So we are given this parallelogram ABCD and we need to explain why AB, which is this vector, A to C, which is this vector, and B to D. So these three vectors are linearly independent with each other. So we need to explain why it is so. Well, as you can see, we know if you see AB and AC, now AB is not parallel to AC, right? Therefore linearly independent. Similarly, you can see AB is not even parallel to BD, right? They have a common point and goes in the other direction. So AB is not parallel to BD. Therefore, they are not linearly independent. So similarly, if you consider BD and AC, we have the same condition, right? So we have BD is also not parallel to AC. So if you see with each other, they are not parallel. So that is one reason when we say that the vectors are not parallel, then we say that they are linearly independent. Dependent vectors are always parallel. That is first way of writing. The second way is writing a scalar combination, linear combination of scalar equations, which is if I say m times AB plus n times, so we are AC for example, can I get it 0 where m and n are both non-zero? At least one of them is non-zero. Can I prove this equation? So we will find that that is never true. So AB and AC, whenever you add them, you will not get a 0 vector unless and until both m and n are 0, right? So this equation is 0 only if m equals to n equals to 0. So that is another reason why these two vectors are independent vectors. You see that? So that's another way of writing the same thing. Similarly, we can say that m times, that means m is any scalar, times AC plus n times BD is equal to 0 only if and only if m equals to n equals to 0. So that is alternate way of saying so that these are independent vectors. So we could actually answer this question in two different ways. One, by using the definition that the vectors are not parallel, right? And the other, that the linear combination of these vectors is 0 only if the scalar multiples are 0, not otherwise, right? Both the scalar multiples are 0. So these are the two ways. So one way in which you can prove is they are not parallel, or you can say linear combination is 0 if and only if both scalar multiples are 0, right? So only then that linear combination is 0, not otherwise, right? So that is how we can show that these vectors are independent vectors. Thank you.